Hello physics students, this is Mr. Wilsey, and in this video we are going to work out the two problems that was in this little quiz on Newton's second law. So let's look at problem number 1. Jack pushes an 8-kilogram box across the floor with an applied force of 32 newtons pointing to the right. The box accelerates at a rate of 3 meters per second. Fill in the blanks below using the correct units. So let's just go ahead and fill out all of these blanks that we know directly from the problem. So 8-kilogram box. The 8 kilograms, that means we know what the mass is. The mass is 8 kilograms. Now we know that the applied force is 32 newtons, pointing to the right. And the box accelerates at a rate of 3 meters per second. So 3 meters per second. Alright, so that is all we know directly. But the first thing that I can calculate from all the information I have is the weight. Weight equals the object's mass times the acceleration due to gravity. The acceleration due to gravity, remember, is always 9.8 meters per second. So in order to find the weight, all I need to do is multiply 8 times 9.8. And that is 78.4. So the weight is 78.4 newtons. Now, once I know the weight, and once I go back up here and read that we are pushing this box across the floor, that means that this box is sitting on a horizontal surface. Because of that, the weight must cancel out with the normal force. That means the normal force is going to have the same exact magnitude as the weight. So that's the next thing I know. Now, I also know that the mass and the acceleration. Because of that, I can use this formula. Acceleration equals the net force divided by mass. Remember, this is Newton's second law in equation form. I know the acceleration, I know the mass, I can find the net force. Just multiply both sides by the mass. So all I need to do is take my mass multiplied by my acceleration. 8 times 3 is 24, which is the net force. So the net force is 24 newtons. Now, the next thing that I can find is the kinetic friction force. I know that I'm pushing in that direction with 32 newtons, and I know that my net force is 24 newtons. Actually, now that I think about it, let's see. We need to figure out what the direction of the net force is first before we can find what that is. Now that I'm thinking about it, I think that a very common answer that students put down for the kinetic friction force, which was 56 newtons, and they got that by adding 32 plus 24 to get 56. So in this case, they were saying that the net force points to the left. But now that I think about it, that actually could be correct, given all the information that I see up here. That wasn't what I was going for, though. What I was going for was that the applied force is causing the box to accelerate. So I was hoping that you would see that the applied force is bigger than the kinetic friction force. So the net force is going to point to the right. The net force points to the right. Now, because the net force points to the right, that means that in order to find the kinetic friction force, we need to take 32 minus 24 to get 8 newtons, right? The applied force is pushing that way. The kinetic friction force is trying to go in the opposite direction, so the 8 newtons of friction takes away from the applied force. Now, once I know that the net force points to the right, I know immediately that the acceleration also points to the right. Because not only does Newton's second law say how to find the acceleration, how to calculate it, it also tells you what the direction of the acceleration is. Acceleration of an object is always in the same direction as the net force. Always, no matter what. So these two directions are always going to be the same. So we're done with that problem. Now let's move on to the next one. Jill is skydiving with a speed of 52 meters per second when she opens her parachute, her speed slows to 9 meters per second within 3.4 seconds. If Jill has a mass of 60 kilograms, find the force of air resistance in newtons the parachute exerted on her during this time. Fill out the diagram to help you. So ultimately what we want to find is the force of air resistance, but we need to fill out all of this stuff to figure that out. So let's fill out what we know immediately. We know that she has a mass of 60 kilograms, so that's easy enough to find. Once I know her mass, I know immediately what her weight is. Weight equals mass times the acceleration due to gravity. So weight is 60 times 9.8, which is 60 times 9.8, 588. So her weight is 588 newtons now. Alright, what's the next easiest thing we can find? Well, let's look at what we're given. We are given a speed here, we're given a speed here, and we're given a time. Now, we start at that speed, then we deploy our parachute, and we slow down to that speed. That means that this is our initial velocity, our initial speed, and this is our final velocity, and this is the time interval over which that change occurred. Now, from these three quantities, I can find the acceleration. How much did Jill accelerate during this time? Now, remember this formula, I hope. Acceleration equals the change in Jill's velocity over the time interval. So this is her final velocity minus her initial velocity divided by the amount of time it took to change. So if I just plug in the numbers that I have, her final velocity is 9, her initial velocity is 52, and her time is 3.4 seconds. Now all of these have standard units, so I can just plug those in the way I did. So 9 minus 52, and then divide by 3.4, negative 12.65. The units of this are going to be meters per second per second. So her acceleration is negative. That means that she's slowing down. Now, if she's slowing down, actually, let us quickly draw a different kind of diagram here. This is going to be her velocity diagram. Now, you know that she's falling. Okay, she just jumped out of a plane. She's falling, so she's going down. Her velocity points down. But over time, so for example, if this is her velocity 52 meters per second, after a time interval of 3.4 seconds, her velocity has become 9 meters per second. So her velocity is decreasing. Now, because of that, her change in velocity goes in the opposite direction. Her change in velocity goes in the opposite direction. Okay? That arrow plus the change gives that arrow, which is shorter. That means that she lost velocity. She lost speed. Now remember that this change in velocity, if you watch the other video, the change in velocity points in the same direction as the acceleration. So her acceleration points up. I realize it's kind of awkward to say her acceleration is that to the up. Yeah, that doesn't make any sense. But her acceleration points up because she's losing speed and her velocity points down. Okay? So they point in opposite directions. Now, because the acceleration points up, I know immediately that the net force also points up, because acceleration and net force always point in the same direction. Now, I know her acceleration and I know her mass, so I can find the net force using Newton's second law. F net over m equals the acceleration, so the net force equals mass times acceleration. So all I need to do is take my mass, multiply by my acceleration, 60 times, the negative here just indicates that she's losing speed, but don't worry too much about the negative signs here. Negative 12.65, negative 759, Yeah, I'm just going to forget about it. I'm just going to forget about that minus sign. You know what it means. It means she's slowing down, but I don't want to deal with it. So I'm just going to make all this stuff positive, 759. So that is the net force. Now, if the net force is 759 newtons pointing upward, that means that we know that the air resistance has to be bigger than the weight. In order to find what the air resistance is, I'm going to take her weight and I'm going to add the net force. So 588 plus 759. Oh my goodness, I multiplied them. 588 plus 759. 1347 newtons. Okay?